Okay, guys, today we're going to learn about understanding the difference between a series circuit and a parallel circuit. There is a difference because a lot of times when you're calculating this kind of stuff, you can run into confusion, especially if you're working with a series parallel circuit where both principles are combined. That can be a problem. If you are facing confusion with that, please see my other video on the series and parallel circuit analysis. All right, and you will learn better how to understand a series parallel circuit. So we're gonna work on first understanding a series circuit first. All right, so I'm gonna draw like a simple circuit here. I want you guys to get this and get this understanding. All right, so I'm gonna draw a very simple circuit here. I'm gonna draw a little resistor. All right. Resistor can be a load or whatever, but this is the symbol that we use mostly as while we're teaching the subject. We're gonna draw a little battery, a little battery, right? So we have a little battery there. Now this is a resistor. We're gonna put the letter R there. Now this resistor in itself, it is neither connected in series nor is it connected in parallel. It is just a circuit, a simple circuit. Okay. There is no series or no parallel attached to it. Reason being, in order for you to have a series circuit or a parallel circuit, this resistor has to be connected with something else. So the particular way it is connected with something else determines whether it is a series circuit or it is a parallel circuit. All right. So I'm gonna put the battery. This is the battery here. I'm gonna put the battery at 12 volt. It says a 12 volt battery, and the current flow is from this direction. So it's gonna flow around here, go through this resistor, and come back around back to the source. All right. So this in itself, as I said earlier, is no circuit. Is no parallel nor series circuit. So I'm gonna draw next resistor here. Here we go. We're gonna add a resistor to the circuit. All right. Here we go. So we're gonna label this resistor. Let's call it R1. We're gonna call this resistor R2. Okay. So remember, the current flow is flowing from this direction. So this resistor gonna receive the current first, and this is gonna receive it after this resistor. All right. So we call this R1 and we call this R2. Now it is a series circuit. Reason being because the current is only flowing through one path through the loads. So it has to go to this resistor and it has to go to this resistor. So it's a series. So it's one after the other. Hence the name a series circuit. If I should destroy this resistor right here, then this resistor will not work because the circuit would have been incomplete. Right? This resistor would be dependent on this resistor for it to work. Also, if I should destroy this resistor here, then there will not be a complete path for this resistor to work. You get it? So hence it's called a series circuit. But there are rules applied when you're doing calculation in series circuit to understand basically how this to calculate series circuit without being confused, especially as I said when you're doing the combination. So what you have to know, there are things you have to know about these kind of circuits. A series circuit like this, the current would be constant. Alright, so which means the current doesn't change. So if I have a current flowing through the circuit of, let's say, about 1 amp, then 1 amp would be flowing through the entire circuit. So this resistor would have 1 amp, and this resistor would have 1 amp as well. But a next thing you have to note about series circuit is that the voltage changes. Alright, so the voltage changes, alright? So meaning that this 12 volt right here would be different in both resistors. So if I have a resistor, let's say this resistor is 4 ohms, and this is, say, 5 ohms, then the voltage is going to be different from here. Alright? Well, versus if the resistance value were the same, like for instance 4 and 4 or 5 and 5, then it would have been split into two. So it would be half of the voltage here and half of the voltage here. But yet still it will be still different from the load. So you wouldn't have the 12 volt in any one of these resistors at any point in time. it will change. All right. So that's the thing you have to know about when calculating series circuit, so you don't run into confusion. And if you're applying this rule to a series and parallel calculation, then you will avoid confusion by knowing this little principle right here. Now we're going to go ahead and draw a parallel circuit. Okay, here we go. So once again, I'm going to draw a little circuit here, like a simple circuit, like this. And once again, viewers and subscribers, these kind of things are very easy to work. Once you know how to do it, then you begin to master circuits, and you will understand that you don't have to be confused. A lot of students get confused sometimes, but you have to just know the principles on how to analyze it to actually work it out well and avoid confusion. So I have 12 volts again, and I'm going to label this resistor here. I'm going to call it R1 this time, all right? So this resistor again is not either series nor parallel, because once again it has nothing to be connected with. So it is just simple, what we call a simple circuit, one load and the source. Now we're going to add a different resistor to the circuit, and we're going to add it in parallel. Here we go. There you go. We call that resistor R2. Now it is in parallel. Why? Because the current gonna flow here, and when it reach here, gonna split, come down to this resistor here, go back to the source. Some of the current gonna flow here, go down to this resistor, and go back to the source as well. So hence you have multiple paths for the current to flow. Do you see that? There are multiple paths for the current to flow, and therefore we'd have had a parallel circuit, viewers and subscribers. All right. So there are two rules as well you have to note about parallel circuit, and these are the two rules. We're going to start with the current again. So this time it's a different way around. The current change and the voltage constant. It's constant. All right. There you go. So the voltage is constant and the current changes, which mean if I have, for instance, 2 amps coming through the circuit, 2 amps of current flowing in this direction, you're going to have some of the current going to flow here and some going to flow here. So in any point in time, you will not have 2 amps going through either of these resistors, because the total current is 2 amps. You will not have 2 amps flowing through any of this resistor at any point in time. It's going to be less than 2 amps. All right. So that's how you do it. Now, if you should combine these two circuits together, then you'd have to calculate each principle different from each principle, and then when you're ready, now you add the values together to get your final or total current within the circuit, or your total resistance, or whatever. All right. So I'm just showing you guys, do this video to show you guys the difference between the two, so that the guys don't get confused. And if this video helps, please like, share, and subscribe, and leave a comment. Let me know if there's something I've missed or didn't mention, so we can make a better video or make adjustments next time. Thank you for your continued support, viewers and subscribers, and continue to make it Green's Electrical School